refers to a lot of aspects which actually encompass the smart water management. And finally, the veracity. And veracity for us, for me would refer to the accuracy of information. And over here, veracity refers to the importance of metering, the importance of monitoring. Whether we call about real-time monitoring, sensors, SCADA, all put together. I think these are all instruments and tools to improve the veracity and our confidence that we have in defining how smart are we on water management and therefore smart water management. So, so in fact, these are the four aspects that that one would see in various forums that we are going to discuss. And finally, the big elephant in the room. The big elephant in the room is how do we pay for the service? The pricing mechanism. And I think we all, as important, speakers over here, you all have been leaders in this field in your own ways, and you have. So the pricing mechanism today, again, it's something not very difficult. We see very good models, as you know, be it a hybrid annuity model, something that NMCG has also practiced for wastewater. Can it be applied seamlessly to water supply systems? Or we have also seen a lot of good success for municipal bonds. How municipal bonds in Ahmedabad, in various other parts of India, how have they performed? Can it be replicated? Soon, we also more recently hear a lot of buzzword around green bonds. We hear a lot of buzzword around the fact that are we going forward going to have markets which are really going to determine how much finance would come from markets to something like smart water management, be it through even mutual funds. So these are some of the areas I think which would be really very interesting from an overall perspective to bring to the forum, to have discussions on these topics. And I think this is exactly what this webinar series aims at doing. It will discuss all these various elements which capture source protection, source reliability on the volume side. It will capture the variability in demand and estimation of demand and its demand management on the velocity side. It will cover quantity, leakages, losses, quality on the variety side, and it will aims to cover accuracy with respect to monitoring, metering, SCADA, real-time sensors through the veracity side. And certainly it aims to cover the pricing mechanisms and the pricing models where which are really good and which can be tested, tried, and scaled up. And from all of this, we really tend to generate a lot of awareness among the delegates. We really aim to generate lot of capacity building work that among various stakeholders. And finally, we would also look forward to making a difference on the ground by taking up or by encouraging certain good pilot studies, or by encouraging and promoting good thinking around this particular subject, which is smart water management. And as our cities are growing more smarter, I think water would need to have kind of a multiplier effect in terms of becoming more and more smarter to make cities smart. So I think we have to be one step ahead of the smart city, so that water can lead the smart city missions. So with this, let me welcome and introduce my my co-panelist over here in the opening session, which is Mr. Pankaj Poddar. He will be the one who, before he I invite him to give away his keynote and deliver his keynote remarks. I would really like to briefly introduce him to everybody over here, and certainly to all the delegates who are listening. Mr. Poddar is the Chief Marketing Officer in the role of Executive Director in Electrosteel Castings Limited. And certainly Mr. Poddar, his background, he's a chartered accountant. He actually comes from the finance, which is the big thing in the room, when it comes to smart water management. He has not only a chartered accountant, he's also company secretary, he's also an MBA, that too from a very elite school of, Indian School of Business, Hyderabad. And he has a huge experience in electro steel, over 27 years. who has been responsible for growing Electrosteel and various departments in Electrosteel, especially the export department, which has grown to a big size under his leadership. And if I, if he is really, the more I understand is, he is responsible for a lot of global export of Electrosteel to many, many countries. I think it's over 100 countries in the world that, he has been responsible for. So basically a very, very kind of, I would say, a very important role that he is playing in Electrosteel castings. But more than that, I think Mr. Poddar is somebody who is also very future, who looks into the future. And I would really compliment, his and his leadership in terms of looking at how smart water management would play a role, not only from a business development point of view, but also more importantly from capacity building point of view. In terms of how important it is to really to have this element and various elements of smart water management in place. So, Mr. Podar, let me, without taking much time, let me request you to please come in and also give your keynote remarks. Yeah, can't hear you, Mr. Podar. In case you're speaking, can't hear you. Slightly better, but if you can come a little more closer to the phone, please. Yeah, microphone. That might be better. Yes.
One moment. Is it now better?
Y- Yes, it's better. It's only echoing. Huh? You might have to switch off one of the media and have only one media is on a switch on mode. It's echoing. Otherwise.
Okay, now I think it
No, it's still echoing.
there. Manoj, just one minute. I think now it should be okay. Now, there's still one.
Still, the volume of your speaking is very low.
Yeah, if you could try it again, Pankaj, just try it again, please.
Yeah, I think. No,
No,
there's
it's a lot of echo is coming in.
still an echo. What you can do? Why don't you call Sanjay once?
Now we can talk.
No, now try it out, please.
Hello.
Yes, now it's better. Yes, now it's okay. Yes, it is audible. If you can just come a little more closer to your microphone, that will be great.
Dr. Narula, you are on mute.
No, who is on mute? I'm on mute.
Yeah, now I can hear you. Yeah, but
There's still a
yeah, it's very.
No, there is a lot of echo coming in. Lahiri ji, there is a lot of echo coming in.
Yeah, just.
Yeah, would you like to try it again? Okay, so I think while Mr. Poddar and team is really trying to get onto this, what we can in fact do in the meanwhile is, Ajay, if you can give us a quick update on how many people have finally joined by now, and where are, how is it looking like?
Uh, yeah, so Kapil, we have about 165 people who have already joined, and there
Very
are people, still joining in. So I
And
think
any
we
idea on
expect
the
about.
good? That's a very good number. But any idea on the composition as well, Ajay? Any idea on the composition?
So we have, yeah. So we have a mix of delegates. We have people
Can you
from
hear
the
me now, Dr. Narula? Nice.
Yes, it's much.
Yes.
It's very good now. Yes. Mr. Poddar, can you hear me? Am I audible?
It's not coming here. Just see, अभी देखो echo हो रहा है. Echo हो रहा है, फिर उनका आवाज कभी नहीं आ रहा है. क्या हो रहा है ये?
I think we can hear you now. It's much better.
Yes, Mr. Poddar, we can hear you now, but I think he can't hear us now.
Speaker on আছে.
Yeah, hello, can you hear us now? No, I think he can't hear us now. I hope I am audible to everyone, right?
Yes, sir.
Okay. Yes, I don't. Yeah, Mr. Poddar, if you could repeat that, can you hear us now? No, I don't know if they can hear. Lahiri ji, can you hear us? No, I don't think so. There's a major technical glitch at their end, it looks like. Can you hear us, Lahiri ji? No, we can't hear you at all. In case you can hear me, we can't hear you. Okay.
I think so. We can mute all the systems and just one system can use that.
Yeah, I think they're trying, Shilpa. They're trying to do that.
Yeah, correct. Sir, are we audible, sir?
Yes, we are audible. No, I'm audible.
Okay.
Yeah, Pankaj ji, what's the position at your end? Are you able to hear us now? Okay, that's great. I can see Mr. Poddar actually saying yes, he can hear us.
Yes.
Okay, I don't know if
Kapil, maybe we can start with the presentation if you can invite Dr. Dhinadhyalan first, and then in between, there, Mr. Lahiri is saying they're trying to rectify the issue. Once
Okay.
they, rectified it, then they will pitch in between.
Sure, certainly. So I think this. Let's move to the main session, and we can have we would request Mr. Pankaj Poddar to come in as soon as his systems are in place, and they are rectified. So Mr. Sudipto Lahiri, who is the senior general manager, was supposed to be the session moderator, but I can see him sitting right, very close to Mr. Poddar in the same room. So friends, he will, the same issue is also with Mr. Lahiri. He may not be able to, moderate the session till the time the systems are up and running at their end. So I will try to basically cover it for him and would request him to come in as soon as his systems are up and running. So may I request Mr. Dhinadhyalan, who is advisor with CPHEEO, a very important, organization who basically sets the standards, who are basically setting the guiding principles, who are basically setting very important protocols in terms of defining water supply, sewerage, and certainly we request Mr. Dhinadhyalan, with the advisor CPHEO, Ministry of Housing and Urban Affairs, Government of India, to kindly share his comments and share his views on a very important subject which looks at benefits of 24/7 water supply system and a case study of 24/7 water supply project in India. Dr. Dhinadhyalan, over to you, please.
Good afternoon to everyone, organizers, participants. Basically, I would like to explain the ministry's initiatives on drink from tap with pressurized system, 24/7 pressurized system in urban India. As far as CPHEEO is concerned, the CPHEEO was established in 1953 based on the recommendation of Environmental Hygiene Committee, which was set up in 1948 to promote environmental hygiene in the country. The Environmental Hygiene Committee had made various recommendations with respect to urban planning, housing, water and sanitation. There are several recommendations. In respect of water supply, they made one important recommendation at that point of time, 1949, that intermittent water supply system, which are prone to contamination of drinking water in the pipeline during non-supply hours, should be discouraged and converted to continuous 24/7 water supply systems. They also recommended that all the community to be educated to adapt themselves to continuous water supply so that the water supply consumption is reduced in case of 24/7 water supply systems. They also pointed out that at the point of time, Lucknow was implementing 24/7 water supply. That was the case in 1948. They set an example that should be propagated throughout the country. Thereafter, last 75 years, we could not move on, and we are implementing schemes based on the different manuals published by the ministry at different point of time. Though, as all of you are aware, all water supply systems in the urban areas, or maybe in case of rural also, are planned to achieve 24/7 water supply. After implementation, they switch over to intermittent water supply. This is the situation all over the country. So let me come to the point how we are going to switch over from intermittent to 24. That I will explain gradually. Now I would like to give the overview of urban water supply. As per NITI Aayog report, 93% of population has access to basic water supply. Under Amrut program, Amrut 1 2015, about 1.41 crore new tap connection was provided. As I informed, water supply in all the towns are intermittent, which causes contamination of water, and all you are aware that NRW is very high in the order of to the extent of 30 to 50%. So the Sudipto University conducted service level benchmark in 900 cities from 5 states and southern states. They have come up with some indicators which was published in 2019, according to which the extent of water supply duration, that is 24 hours is the benchmark, as against 24 hours, only 2.7 hours is the water supply duration. Is the average figure in 900 cities. NRWs 31%, extent of water meters is 22%. Next. Sometimes we always say that there is no water, we can't go for 24/7 water supply. In some countries, even with 100 LPCD, even with 70 LPCD, in the African countries, in some cities, water supply is 24 hours. It is possible to have 24/7 water supply at least with 100 LPCD. But I would like to quote, in many cities like Goa, Chandigarh, Mumbai, Delhi, the water supply is ranging from 170 to 341 LPCD, but the duration of water supply is ranging from 2.5 to 10 hours. I would like to highlight some of the major challenges in urban water supply system. Water supply intermittent, normally it is from 2 to 6 hours per day. In some cases like Hyderabad, water supply is given once in 6 days. This is a situation in some parts of the country. Contamination of water in pipeline during non-supply hours, high NRW, inequitable water supply, limited metering and non-functioning of water meters, unbilled water consumption, and theft contribute to NRW, resulting into poor sustainability, lack of commercial orientation for revenue generation and sustainability aspects, lack of autonomy to the water utilities to implement tariffs, lack of reliable data, both at national level and state level and ULB level. Next. So these reasons for intermittent water supply, the planning of water supply is done on ad hoc basis, though it was done with hydraulic software, but the system are not planned in a decentralized approach. They are going with so many number of households in a particular zone, which will create a lot of problem in the system after implementation. Heavy like leakage, unmetered water supply, unplanned development of city, low tariff to sustain O&M, lack of capacity of ULBs to manage 24/7 water supply. So how intermittent water supply contaminates water? When there is during intermittent water supply, during non-supply hours, there is a vacuum which is created in the pipe. The outside water enters, wastewater enters the system, water is contaminated. If you pressurize the system on continuous basis, this can be arrested, prevented. Next. And one more issue with our system, most of the households, they are using underground sumps. As per the study conducted by NEERI and VNIT Nagpur, even in Nagpur water supply scheme, wherever these households are surveyed, 50% of the total sumps are source of contamination, and also it is also water is lost through seepage. This is what the observation. The study was conducted recently by both these organizations jointly. I would like to also discuss the minimum residual pressure as per the existing manual. The minimum pressure for single-story building 7 meter, 2-story 12 meter, 3-story 17 meter, 4-story building 22 meter. But I have appraised so many projects under JNURM, under AWSP, under even Amrut, some external finance schemes. Most of the cities have, even for class 1 cities, metro cities, they plan maximum of 12 meter head, residual head. Some city, even Coimbatore, they have done this 7 meter. This is the situation in the country. I would like to also highlight the 7 meter, 12 meter, 17 meter were recommended by Environmental Hygiene Committee in 1948. Still, we are following the same residual pressure, irrespective of the size of city and the vertical growth of buildings in the cities. Next. I would also highlight internationally, many cities, they have gone for higher residual pressure. 28 meter. In Canada, USA, they are going for 25 to 32 bars, 32 kg per centimeter squared. In other cities, in Australia and other places, they are going for more than 25 meter. In case of Israel also, recently I visited, they have also gone for more than 2.54, that is 2.25 kg per 2.5 kg per centimeter square. So what is the government of India vision? So it has been decided by the ministry and CPHEEO to adopt decentralized planning with the formation of operational zones and district meter areas, to design, implement urban water supply system towards equity, quality and sustainability, to distribute water equitably and gradually achieve drink from tap facility with the 24/7 pressurized system. So I would like to, I think most of you are aware that 24/7 water supply will prevent the contamination of water, because we are going to maintain pressure all the time, throughout the week, throughout the year. Reduction of waterborne diseases, reduction of non-revenue water, so on and so. Next. I think you are all aware, Government of India launched Amrut 2 in October 2021 with the objective to make all cities to water secure and provide functional tap connection to all urban households. The total indicative outlay was rupees 2.77 crore, which will be implemented in the next 5 years till 2025-26. The target for providing connection is about 2.6 crore new connections in all 400 statutory towns. I would like to highlight that the last 72 years, first time in the country, the Amrut mandated all class 1 cities to implement 24/7 water supply facility with the drink from tap facility, at least in one zone of these 500 cities. Please next. Please move. So, Ministry also drafted national policy of drink from tap in urban India. It has been prepared recently. We had consultation with the various states. We received comments. Very soon this will be finalized by the ministry. Next. Next. I would like to highlight that you are all aware, CPHEEO has published various manuals. The one manual on water supply and treatment, which was published in 1999, and the O&M manual for water supply, which was published in 2005, are about 24 years old. This could not be revised last 24 years. Now, in 2021, once I assumed the post of advisor, I took up the revision, and the entire manual has been revised now in 3 parts: Part A engineering, Part B operation maintenance, Part C management. It consists of about 39 chapters. This work has been done with the assistance of GIZ, and once the draft is finalized, the ministry has communicated all the chapters to the international consultant, USA, to review all the chapters so as to get the feedback in international best practices. And also we had consulted with all states on 12th and 13th of June 2023 last month only, and we invited about 300 people. We had a larger stakeholder consultation. We received comments. We are incorporating all the comments in the manual now. Next. Next. So what is missing in the current manual? I would like to highlight that the concept of tap is missing, though the system is planned and designed for 24/7 water supply. But after implementation, as I said, it is switched over to intermittent mode. So what are the lacunas? What are the issues? How we are going to migrate and all that is discussed in the current manual. So what we are coming up with the new concept of planning and designing based on GIS hydraulic modeling. And we are going for a decentralized planning with operational zone and DMA. And basically we are saying how we are going to retrofit the existing system to move from intermittent water supply to continuous water supply. And also we are coming with methodology how to migrate from the current supply to 24/7 water supply for existing system as well as new system. Next. Basically, we are recommending that each operational zone will have about 50,000 population maximum, and it will have 3 or 4 DMAs. It may be ranging from 1 DMA up to 4 DMA. Each DMA will have about maximum of 3,000 connections, ranging from 500 to 3,000 connections. In hilly area, we have recommended about 500 to 1,500 households in 1 DMA. And basically, we are now coming with the, residual pressure. Go to next slide, you will come to know. So, in the past, we have recommended 17-meter pressure, residual pressure for 3-story building, which are applicable for class 1 cities. Nobody has followed it. All systems are planned either with 7-meter or 12-meter. I think all of you are aware, all engineers, all utility managers were all aware. Now we are coming with the residual pressure 17 to 21-meter range in class 1 and class 2 cities. For other cities, it will be like 12 to 15 meters. For rural areas, we are coming with the 7-meter head. In case of some city, Ministry of Jal Shakti also recommended to adopt FCV with the control valve. There we have recommended 12-meter head in rural areas. Oh, next slide. The objective of the manual is to divide in 3 parts. Part A, to provide planning, design, and implementation methodology of water supply system so that city will supply potable water equitably and sustainability. The main idea here is the intention is to provide guidelines in the planning, design, and implementation of achieving 24/7 water supply, moving from current existing supply to a 24/7 water supply system. This is what we are recommending. And part B talks about how to practice the O&M for the system which is created for achieving 24/7 water supply. The part C talks about management of 24/7 water supply systems. Next. So I would like to highlight the strategy. So what we are trying to highlight the strategy in planning and design implementation. See, this is the present system. What are technical parameters? The city or the project area. Suppose sometimes city will go for a complete planning of a project of water supply project for the complete city. Sometimes they would like to go for a small area, maybe 1/3 area or any area 50%, 25%. That is called project area. The project area to be chosen based on the command area of any water source. Suppose if you are taking one water treatment plant, which is serving one command area of about 25% area, I request city to take up that area and prepare GS-based hydraulic modeling. With that, you will be able to form operational zone and DMA. But initially, all the systems, whatever you are going to create, DMA and operational zone, all such DMA will have to be designed with a terminal pressure of 17 to 21 meter. Somebody may go for 21, depending upon the local condition. They may go for 17 or 21. Basically, we have given the range, considering the head loss in the house sections. Therefore, we kept the range. Somebody will go for 17, somebody will go to 21 meter. Maybe some metro city will go for 21 meter. But we are also recommending 100% metering for measuring the consumption. Basically, here, what is going to happen with all these modelings, we are able to identify illegal connections, and also we are going to rehabilitate the existing network. The most importantly, the pressure management is very important. Everybody thought that, even now all participants may be thinking whether existing system will be able to withstand 21 meter. That is the question now everybody will ask. I would like to reply. Initially, we are not going to increase the head to 21 meter residual head, residual pressure. We are going to form only DMAs and operational zones. Whatever the available head, the system will be operated with the 24/7. gradually the NRW reduction will take place, and also we have to move towards 17-meter head. So the point what I'm trying to say, that sums which are source of contamination, that should also be gradually delinked in future. By the time system is stabilized, gradually we will increase the head also to 17-meter, and all the systems, the sump and all will be eliminated gradually. So in case of the existing system, the residual head will be increased gradually from whatever the available head, maybe 7-meter, 10-meter, it will increase to 17-meter or 21-meter. But for the uncovered area, wherever we are going to construct ESRs, the staging height will be such that it will create residual head for 17-meter. I want to separate both the existing system, the head will increase from the existing condition to 17-meter gradually over a period of 5 years or even 10 years. In the uncovered area where we are going to provide new network along with ESRs, the residual head will be 17-meter. There also we are going to recommend pressure regulatory valve to regulate the pressure depending upon the local situation like the leakage and other things. The reduction of NRW and increase of pressure will take place simultaneously to reach a situation that water will reach up to 3rd floor. You may ask one question that why you will not talk about 3rd floor, because majority of the building in the cities are 3-story building. For buildings above 4, more than 3-story, we allowed that every building will have their result, some with Pakka material like RCC and maybe some HDP tank. There, the ULB are mandated to monitor the tank once in a month. Regularly, the cleaning should take place once in 6 months. This is recommended to maintain water quality meeting the standard IS 10500-2012. In addition to technical parameters, we should also take up organizational, commercial, and policy and budget aspects. We need to take up O&M very seriously, because this system will be able to be operated very efficiently like Nagpur. Though they have implemented now with 2-meter head, they are operating 24/7 water supply. I am told that they are going to increase the pressure by installing VFD. I think they are recommending VFD also for improving the head from the current system to 17-meter. And all meters will be installed in the commercial and the residential building so as to measure the water quantity. And there should be management contracts. We are coming with PPP guidelines that also explain. Then there must be adequate O&M to take care of O&M and other capital expenditures, so as to achieve finally 24/7 water supply. It is not that it is going to happen within 5 years, but we have to make a new beginning. If we lose now, we cannot do even next 50 years. We have to make beginning, every city to work on that. Next, please, next slide. So I would like to highlight what are the salient features of the manual. The concept of drink from tap is brought out. Planning, design, investigation of water supply system should be done properly with proper survey. Modern technology of G Sasidharan modeling, systematic removal of consumer underground tank, water to reach 3rd floor. I explained about pressure. Peak factor, we have recommended 2.5, we eliminated 3 and 2 and all. We have got this figure from the Puri water supply system, which was commissioned in 2021, which is running efficiently. They conducted the peak factor. Since we are recommending 2.4 24/7 water supply, we have considered 2.5 as the peak factor. And we also brought up the concept of operational zone and DMA, reduction of NRW less than 15%, equitable distribution water will be ensured. New technology of VFD pumps is introduced to increase the residual head. New methods of treatment. In respect of treatment, we have recommended advanced technology for treating wastewater that is receiving wastewater in the water body. I think we have come up with conventional treatment for treating wastewater for normal conditions. Some rivers polluted, highly polluted, we are recommending advanced treatment technologies. O&M methodology with IT solutions like SCADA. We are also recommending industrial IoT for monitoring water quality parameters and other parameters in distribution system. And we are coming with financial management and PPP also in the parts manual. Next. See, we have also come up with one chapter on 24/7 water supplies, a PPP in 24/7 water supply. Basically, we are recommending that PPS. I agree with all of you. PPP is a dream for us in water supply system as of now. The moment we switch over from intermittent to 24/7 water supply, definitely PPP will be pitching. To start with, we advise all the states to take up PPP in 1 or 2 DMAs or few wards in a particular city. They will learn the experience. They will undertake all the so existing conditions. Then they will go for upscaling of the PPP for the entire city for successful PPP projects. Next. So after completing the manual, draft manual, we had organized this workshop in Delhi. We invited all the states. We had consultation. We received comments. Now the expert committee is finalizing all the comments. We will be incorporating all the comments now. Simultaneously, last year, I think 2022, next, go to the next slide. I moved a proposal to constitute National Task Force on 24/7 water supply. The committee has been constituted under my chairmanship. We conducted 2 regional workshops inviting 22 states, and we had also conducted regional state level workshop at Kerala, inviting so many states and cities to educate how to plan, design 24/7 water supply system. I think now we have received information from about, go to next slide. 17 states have reported they are implementing 24/7 water supply systems in 318 cities. I would like to also highlight that Government of Orissa has commissioned Puri water supply system, which is 24/7 water supply based. They also commissioned Gopalpur town, and 40% of Bhubaneswar also commissioned with 24/7 water supply system, and they are in the process of implementing remaining 20 towns in Orissa at pan city level, not DMA. They are implementing to achieve 24/7 water supply in all 22 cities, and they are also planning for 24/7 water supply in remaining 21 towns in Orissa. I would like to also highlight the Nagpur also implemented 24/7 water supply 1/3 of area. Pune has implemented pan city 24/7 with 219 DMAs. They are now going for one DMA wise to increase the pressure and achieve 24/7 water supply. Ahmedabad also implemented 24/7 water supply conventional projects with the DMA of ranging from 250, I think 260 DMAs. Now they are going to operationalize all the DMAs one by one to achieve 24/7 water supply. Chandigarh is taking plans to 24/7 water supply. Recently, I approved one scheme for Guwahati to take up 24/7 water supply. Many cities, Coimbatore has implemented 24/7 through PPP mode. I think many cities in the country now taking up 24/7 water supply. I appeal and request all the cities and all the stakeholders to move forward to achieve 24/7 water supply, which is need for the country. When Swachh Bharat is happening throughout the country, at the same time, we should think and to provide clean water supply meeting highest standard at every household. Go to next page. Next. Way forward, we are planning to have National Conference on Drink from Tap in the coming September 2023. We are going to publish our manual by September 2023. I requested all the states, Ministry has been writing letter to all the states to have state level workshops for wider dissemination. With this, I would like to conclude. Thank you so much. Thank you. If any questions, I'm ready to answer. We'll discuss after other presentation. Thank you so much.
Yeah, thank you, Dr. Dhinadhyalan. It was, I think, it is a very path-breaking and a very pioneering kind of work, which you have really introduced us to and told us in good detail. about the work that you are doing on the new water manual and the way you are basically taking it to various cities and various states. I think it's really very important messages have really come out from what Dr. Dhinadhyalan has shared with us, and in terms of how they are planning to move from an intermittent water supply system, which has so many challenges, to a much more regulated 24/7 water supply system, completely pressurized, which is going to be, coming out from the grip and from the bad grip of all those challenges that intermittent water supply faces. And certainly very important point that Dr. Dhinadhyalan mentioned is the strategy, towards achieving this, and how this strategy incorporates so many elements, be it GIS, usage of hydraulic modeling, be it, defining your operational zones, your DMAs, and, based on, and also the whole important aspect that it is not going to happen all of a sudden. It is not that the existing systems will be suddenly, be replaced. It cannot happen at that scale. It will be phased out. So there will be a complete phased manner. It will be carried out. Very useful, Dr. Dhinadhyalan. Thank you so much again for this wonderful presentation, and congratulations to you and the ministry, certainly for this very path-breaking and pioneering work. One important question that several delegates are asking, and I think more questions will come in, but very important question that many delegates are asking is, what about Delhi? You mentioned about so many cities, what are your
Yes,
plans for
I would
Delhi?
like to, yes, I would like to highlight that I have approved one scheme, myself approved one scheme. I think Chandrawal command area. In 2000, I think 20, I approved for about 512 crores. I think had it been implemented, by the time the project would have been actually ready. At that point of time, without any guidelines, I have approved the project with a residual height of 22 meter. Then this was stalled due to some tendering issues. It came to us once again through Ministry of Finance. I told I approved. I recommended no, the tender to be issued. They have issued the work order about 4-5 months back. Project is on. I think they have started now. Work is going to happen now within 3-4 years. I think Delhi will get very soon. The only problem I would like to highlight that we don't have proper guidelines in the country. Therefore, people are taking projects the way it is happening, the conventional way. We need to make change. It has to happen gradually. I am coming with a vision statement that 24/7 water supply is not going to happen within 1 day or 1 year, 5 years.
Correct.
I am proposing it with a vision statement. Every urban households will have 24/7 water supply by 2047. Next 25 years, all cities in the country to have 24/7 water supply. We have to move. We have a new beginning. Delhi, definitely, they are implementing one project with the KPIs. I have seen the tender document. They are coming with KPIs. Duration of water supply 24 hours. Terminal height 22 meters. They are coming with KPIs. I hope the project, once it is completed, they are able to get 24/7 water supply. I think recently also there was some message in the newspaper. The government is going to implement 24/7 water supply in future. This is
Thank
what
you.
it came from government of India.
Thank you very much again. I think there are many questions coming in, and I think, but before I take this forward, let me go back and bring in the people who are actually responsible for for the session as well. And so let me go back and request Mr. Pankaj Poddar. I think their systems are up and running now. They have changed the system, as I'm told, they've switched on to another system. And so maybe I can now request Mr. Pankaj Poddar to kindly give his keynote remarks, after which I will like to then invite Mr. Sudipto Lahiri, who is actually the session moderator. But before that, Mr. Pankaj Poddar, again, over to you, please, and request you to kindly give your keynote remarks.
Thank you, Dr. Narula. I'm again very sorry for all this technical glitch that has happened, and we wasted some time. So I'm going to keep myself very short.
Yeah, we
sir.
can hear you.
Everything is
Please
fine.
continue. Yes.
You can hear me?
Yes,
Yeah,
yes, everything is good, sir.
Okay, so is basically, what is the objective of these webinars that we are doing? From our side, what we are trying is that we are uh, trying to bring into focus some very important issues related to water in consultation with the CII team headed by Dr. Narula and tapping into their resources and their knowledge of the space and whatever little knowledge we have in the company. And we're then trying to bring in people who are not only experts, I would say, but who are authorities in those particular areas. So when they come and talk about it, we know what we have on the table or what we have in terms of discussion is absolutely the best knowledge that we have in the country, the way we heard Dr. Dindayal speak now. You see, we all know the land mass of the country and the population of the country. We really need to do things differently, and whether it is saving water, whether it is leak detection technologies, whether it is conserving groundwater, whether it is getting piped water in a way that we do not waste any drop of it to the extent possible, whether getting technology in place so that we are in a position to distribute it equitably to the places that we need the water, because the availability and the need is not always adjacent to each other. And then whatever regulatory frameworks are needed to have all this implemented through the various state governments and the central government is basically what we are all striving to achieve in different roles in different organizations. And what we are trying to do as a company is that we do consider ourselves as a water infrastructure company. And with my little experiences abroad, I think in my first trip to Europe in 2000, in the year 1999 or 2000, it was so surprising to go and take a glass of water and drink from the tap. And that's exactly what Dr. Dindayal is talking about today. And I'm sure I would like to see it in abundance in our country. So I have seen a few technologies. I was also in discussion with some people in Germany as to when they call smart water, we are also calling smart water. And they were talking about something which is a parallel line, which is not, because today we are bathing with that water, we are drinking the same water. So they were talking about something where they have clean water, but not potable water, which is used for gardening and washing and washrooms or whatever. So we have a lot of ideas, I know, and that's the reason why we have people like Dr. Dindyalan, we have people like Dr. Agam Mathur, we have Mr. Sasidharan. So we have all these people, and we have under the guidance of and the knowledge that we have in the CII Water Institute, we will strive in our small way to bring these issues in focus. And we actually really appreciate that we have so many participants today. And let us all go back with some more knowledge, pondering over what we in our small situations and in our small organizations can do. So back to you, Dr. Narula. And before that, maybe Sudipto can now do his bit of
Thank you so much, Mr. Poddar. Thank you so much for these keynote remarks, and I really, kind of look forward to a lot of wonderful, kind of capacity building work that together, with you, the CII Water Institute and Electrosteel Castings will be delivering. And I must mention over here, in the interest of everyone, that this is why this lovely collaboration has come together. As also very wonderfully resonated, when Mr. Poddar mentioned it. And the whole objective is basically to make a difference on the ground, to create that, to showcase that difference on the ground. And as we go forward, we will really make this a lot more exciting. So with this, thank you so much once again, Mr. Poddar, and we really look forward to this lovely partnership with you. And let me now, invite Dr. Mr. Sudipto Lahiri as the session moderator of this session on smart water technologies. He is a senior general manager with the Electrosteel Castings Limited. Again, somebody who has a lot of accomplishments under his belt. He is a civil engineer, and he is also has been, having a wonderful experience of more than 28 years. And, he's, he has been in various capacities looking at water, from different angles, be it integrated water supply, sewerage projects, be it irrigation projects, be it industrial water supply projects, or wastewater effluent pipeline projects in India. And not only India, he also has very good experience of, basically making a lot of good presentations in several kind of forums, be it national and international. And one thing which I really kind of discovered, is his wonderful, I must say, kind of ability. He's an author of a wonderful book, and he has also written this book. And his ability to publish, his ability to write, is something that I have very recently I discovered in one of the meetings with him. And so Mr. Lahiri, once again, welcome to you as a moderator of the session, and I request you to kindly take the session forward.
Thank you, Dr. Narula. Thank you so much for this beautiful introduction. And I'll just first say a bit of sorry for the technical glitch. And then I would definitely thank Dr. Dhinadhyalan for taking out his time from his busy schedule. And we are extremely happy for the presentation that you had made. Very informative, definitely. And I'll start with the moderation of this session. And before that, I'll just take 2 minutes and just supplement what Mr. Pankaj Poddar had said about the importance of water. I'll just say a few statistics which are going to be a bit glaring and which are going to be sort of very much relevant to today's kind of a session that we are going to have. India has got 2% of the landmass and 4% of global fresh water available. Now, as per estimate, in 1951, we were having a freshwater per capita annual availability of 5177 cubic meter in 1951. This has come down to 1545 cubic meter in 2011. And this is further going to go down to 1293 cubic meter in 2025. And if this trend continues, and if we do not act and do the things which our session partners are saying today, in 2050, the availability is going to reduce by 1140 cubic meter, which is very, very low. Now, the global population is growing very fast. And we all know that the entire world, only 1% of the available water is available for drinking. It's potable water, only 1%. And today, the world is facing a crisis. 40% of the areas are falling in an area which is water scarce. And in 2040, it is estimated that 1 out of 4 children are going to live in a water scarce area. So definitely it is obvious that we are heading towards something which is not very good looking, but definitely there are a lot of ways and means by which we can have this rectified by smart water management. And through this webinar series, we are going to take up these topics, and eminent speakers like Dr. Dhinadhyalan, Mr. Agam Mathur, Mr. G Sasidharan, and of course, Ms. Shilpa Nischal from CII are going to value add. So next, I will invite Mr. Agam Mathur for giving his presentation. He is a water and wastewater sector specialist and a retired chief engineer from PHED Rajasthan, a career spanning for more than 40 years in the service of the nation. He has got an engineering degree from MNIT Jaipur and master's degree from All India Institute and Hygiene and Public Health, Kolkata. Presently an independent consultant and director of Saraswati Technical Services, currently working on various programs on water and wastewater, national and international. Mr. Mathur is also a short-term consultant to World Bank and developing model on PPP contracts. During his tenure as chief engineer, he has done prestigious water supply projects under JICA, World Bank, AFD, and ADB. He also supervised the pilot project of reduction in NRW and achieving 24/7 water supplies at Jaipur and other towns. Thank you, Mr. Agam Mathur. Kindly, I would request you to please take up your presentation.
Thank you, Mr. Lahiri. I would share the screen from my computer, and let me see if it works all right. Is that visible to everyone?
Yes, sir.
Okay, great. So before I start my presentation, I thank CII and Electrosteel to give me a chance, give me an opportunity to talk about the non-revenue water or the water leakage in pipelines, which is very close to my heart. And I welcome all the audience, and good afternoon, everybody. So safe drinking water is basic to human life, only next to air. Presently, the drinking water supply systems are underperforming due to several reasons. Leakage in pipeline networks is a major cause out of the underperformance. Sorry. So water leakage in pipelines is basically a subset of the non-revenue water, which consists of technical or physical losses in which the water is lost in soil or drain and is not used. So that's the leakage part, what we are talking. And the other is called non-technical or commercial losses, which could be due to inaccurate metering or theft of water. It reaches the consumers, but it is not being metered. It's not being, revenue is not produced out of it. So this NRW is as a major cause of underperformance of the water supply systems. The classical definition of non-revenue water is that system input, what we input into the system for supply. It has two components: authorized consumption and water losses. Water losses, as I again told you, is due to commercial losses and physical losses. Commercial losses are again unauthorized consumption, and that is theft, etc., and customer meter inaccuracy and data handling errors. So this portion also reaches, but the revenue is not produced. Then physical losses could be leakage on transmission or distribution mains, leakage due to overflows from the utilities. This is also a big component, and this cannot be overlooked. Leakage on service connections. You know, it is not only in the main pipelines. Several studies have found that a major portion of the physical loss in water is due to the leakage from the house service connections, which is the pipeline from the main line to the house service meter, or if it's unmetered, it's the property. So again, leakage in drinking water pipeline is a major concern, but there is no accurate estimate available in absence of end-to-end metering. This is, you know, Mr. Dhinadhyalan said the national average is 30%. What I understand in what I have discussed with so many people, the average works out around 40%. That's In Jaipur, we had a detailed study in a World Bank project where renowned consultants were employed, and they worked out that the water losses in Jaipur or NIW is about 40%. That was an average. They did it for a particular zone. And out of it, 25% was leakage and 15% was the commercial losses. So this could vary from 20% to 60%, or in some cases 70%. CPHEEO manual on water supply and treatment recommends a water loss to be less than 15%. That's a target to be achieved. In Amrit projects, which while I was chief engineer, we started, and as a consultant, we prepared project reports. So we have suggested this. So in some Asian countries, we have data that varies from 6% to 60%. Like Japan, etc., they have the lowest non-revenue water loss figures. Why do the pipes leak at all? So this could be due to structural failure of pipes due to internal pressure. This generally occurs in pumping mains, where the burst could be due to aging of pipe material, loss of strength, poor laying and jointing. Yeah, this is also one of the major factors. If a pipe is not properly laid, the jointing is not done properly, and it is not tested to a specified test pressure, there would definitely be leakages when the system is commissioned. Poor quality of pipes used. This again is a major concern. You know, we have specifications, we have IS codes, but there are quite often than not instances where those agencies, checking agencies are bypassed, and we have a lot of poor quality of pipe delivered at site and installed. And that causes a major problem. Initially, when we joined, we were using asbestos cement pressure pipes. You know, quality of pipe when I joined in 1970 was almost like a metallic pipe. Gradually, there were more manufacturers and local manufacturers. The quality of water pipeline deteriorated, and there was so many breakages after laying, during laying, and one fine morning, the Chief Minister of Rajasthan sat in a meeting by listening to the complaints that no more cement pipes in my state. So on the same very day, the use of asbestos pipes, while we were talking to the manufacturer and saying, unless you improve your quality, hum band nahi kar payenge because your pipes are cheap theoretically. You know, when we do economical designing, your pipes are proving to be economical and we have to use them. But someday public would throw you out, and that's what exactly happened. So this is not only true for AC cement pipes, which was banned, but in the non-metallic pipes like PVC or HDPE also, there's a lot of poor quality pipe being received at site, even after a lot of checking at factory and third-party inspections. And so this is a major cause of pipe failure and leakages. Corrosion in metallic pipes. In mild steel pipes with age, if the protection is not good, corrosion protection is not good, in due course of time, leakages start happening, and it's very difficult to repair and take shutdowns. And quite often, the leakages take place due to damage in pipeline due to digging by other utilities like fiber cable and all that's being laid, and without the permission or without proper investigation of site, they do this horizontal drilling and they damage the pipes. Then due to excessive pressure, pipes are designed for a certain pressure and the operating pressure exceeds due to over pumping head or due to surge pressures. So these are some of the causes of leakage in pipelines. Why control of leakage in pipeline is very important. as Mr. Lahiri has already said, the freshwater sources are limited. The groundwater in Rajasthan particular and in the country in general is almost exhausted. The water table has gone down. In my service area itself, when in certain areas when the water table was 20 feet, it has gone to 120 feet, 150 feet. And the water quality has also deteriorated due to overexploitation. Creation of additional capacity requires huge investments. You have to bring fresh water from distances, surface sources, and that requires huge investments. The reduced availability at consumer end causes dissatisfaction. It causes revenue losses, increased probability of water pollution. You know, you can't have a 24/7 supply in a leaky network. And as Mr. Dhinadhyalan said, it's more often than not a major cause of pollution entering the pipelines when the supply is closed and the water flows out of it and there's a vacuum. Damage to civil structures. When the pipe is leaking near the foundations, etc., the civil structures are damaged. Hindrances to traffic movement. Loss of credibility of utilities. You know, गर्मियों में तो हर water supply system को गालियां पड़ती हैं, and in Rajasthan at least, this every day there's a major headline of failure of water supply, or you know, we have to send tankers and all that. That's is a huge problem. Now, why are we not able to reduce when we know that there are so many problems caused by the leaking pipelines? And everybody knows, everybody appreciates, right from Government of India to the government officials in the states and the engineers. So what we have found out is incompetent human resource. The human resource available with the utilities, the public health department or the municipalities, they are not basically competent enough or trained enough, or the capacity building is required to detect the leakages and repair them. The staff is more project oriented. They are quite happy in taking up EPC works. And there is a lack of commitment. There is no incentive for the utility people, O&M staff, to take up the leakage repair work on priority. The organizational structure. This is, sorry, let me get back to the side. Organizational structure. This is very, very important. In 1990s, we had a study done by World Bank. We were trying for a loan for Jaipur water supply scheme, which was the requirement of 1,000 crore. They said that, yes, we would give you the loan, but there are certain preconditions which you have to meet. They wanted the tariff structure to be reorganized, the present water supply organizational system of Jaipur to be reorganized, and a separate circle, SC level officer, and a proper hierarchy under below him to be created specifically for reduction of non-revenue. Now, the government did not agree on any of the conditions. They think the World Bank is trying to dictate terms, which you know, the political class, or yeah, I mean, the IS class or engineers, they would have agreed. And to me, we even pushed for it, but there was no commitment at the highest level. So one point when we are talking of NRW or 24/7 supply, I would say that there is a lot of lack of commitment at the political level in understanding the sector. High complexity. It is the detection of leakages is not an easy task, which are not available on surface, and there's a huge loss of water. So you have to have instruments a proper training, and then you have to take shutdowns. There's some consumer inconvenience also in leakage repair and all that. So it involves that thing. And this work is less prestigious. You know, when you constructed a new reservoir and lay a new pipeline, there's a lot of paper coverage, and the politicians have a chance to inaugurate new Kato Fita and all do all that thing. So this NRW doesn't, get more of a publicity or coverage. And last but not least is the insufficient funds. There is very little fund allocation specifically for the non-revenue water reduction. I must tell you one on the lighter part of it. In Rajasthan, the chief engineer urban side has been designated as chief engineer non-revenue water and urban. Chief engineer non-revenue water and urban. Unfortunately, he does everything other than reduction of non-revenue. So focus is in none of the meetings at the government level or at the chief engineer level. The parameters of the water supply systems are discussed. We discussed everything else than the physical progress, length of pipeline laid, hand pumps repaired, all those kind of things. But the basic service parameters of what is the pressure, what improvement has been done, what reduction has been done is not being discussed. So these are major obstacles in the reduction of non-revenue water or even the service improvement. You know, the subject is strategy. Common strategy to fit all utilities for reducing leakage pipeline not feasible, but common ingredients. I think Mr. Dhinadhyalan has already discussed much more in much more detail all the points related to it. But I would flag a few issues. So first of all, how much is the physical and commercial losses in the network? We have to know capacity of the operating staff, present organizational setup, last but not least, awareness among consumers. You know, when we are able to read this, then the strategy could be formed. Why I'm saying awareness amongst consumers? When we were preparing projects on Amrit projects and we were propagating, we were discussing with so many people on the need for 24/7. Like in Ajmer, we have water supply once in 2 days, and the LPCD is more than 150. It is simply a problem of management of the water, pressure management, DMA formation. So the collector even said, why do you need 24/7? So there is very little awareness amongst the top echelons, including the politicians, the administrators. You know, Mr. Dhinadhyalan very rightly said that if you have a 24/7, the coping cost of water, even if I increase bill by 200 rupees, I save 300 rupees on boosting of water again at my home. I save on storage of water, basically. So we are not able to make this awareness among consumers that even if we increase your tariffs to fund the project, you would still save. I have made detailed calculations and presentation. I had a chance to make presentation, in-person presentation to chief ministers, both of both the governments, BJP and Congress, and they very much agreed on the suggestions. But when it came to taking actions, the things have to put on file and the things go haywire and they are not considered.
Mathur Saab, sorry for intervening, but we have some time limit. So if you can just...
I'll just rush through.
Thank you.
There's urgent need for well-calibrated strategy for managing and reducing non-revenue water. So technical requirements, we have to find out, funding requirements, organizational requirements, awareness at the political level. Proper planning and design, updated maps. I would say that digitization of the whole system to begin with is the most important thing Today, all the businesses are on digital platform. If you have things on digital platform, the information can be disseminated. You can make people accountable. So updated maps, digitized installation of bulk meters and consumer meters, leak detection equipment, reliable meter reading. Installation of meter really doesn't help. In under project, we have installed lakhs of meters in Rajasthan, but there are no meter readers. So we have to close the loop. For every intervention, we have to see that how is this helping the consumer at the end? How that should be the benchmark of any project implemented. Now, when we discussed about the choose the correct pipeline material, metallic pipes are there, non-metallic pipes are there, then we have to judge between cost and performance. As a public health engineer, I would always love to have ductile iron pipes in all my distribution system, because they are foolproof, easy to lay, most reliable, and there's no problem of quality, because each and every pipe is hydro tested, without which it cannot come out of the factory. So, but in a distribution system, if I convert all the pipelines to ductile iron pipelines, it would cost. So it depends if we really can afford it. The manual provides a matrix for the selection of pipeline. State level, there are policies. So while we try to detect the leakages, the distribution system has to be on a DMA philosophy. In an existing network, you just can't locate a leakage and the extent of leakage unless you have a smaller DMAs in which this is hydraulically isolated and you have a bulk meter installed at the inlet of DMA, and then you measure the pressure, flows, the meter reading every month, and then compare it. Then the laying adequate soil cover, proper jointing, hydraulic testing, adequate air inlet outlet arrangements, surge protection equipments, all these are required for control of leakages. Know your network. GIS map shall include following pipe attributes like material class, diameter, length, etc., pipe connectivity, placement of ancillary structures, placement of walls, location of consumer connections, DMA boundaries, placement of DMA meters. All this has to be on a GIS platform. Controlling leakage is not a rocket science, just need to locate and repair. But even the visible leakages are not being regularly repaired. So this is one point we are lacking at. Non-visible leakage, dedicated manpower for monitoring these leakages on continual basis, locating, using equipment like sounding sticks, ground microphones, noise loggers, and there are a lot of AI-enabled softwares we come across. But unless you have meters, unless you have a 24/7 supply, those all softwares are of no use. Now, as I discussed, IT solutions are very, very much required, integrated management information system, in which the commercial system of billing, meter reading, meter management also is there, network data management, maintenance management system includes mobile app, data analysis module, hydraulic modeling module, GIS-based digital maps, asset registers, inventory, and so, as a consultant working for WebPOS, we had prepared a proposal under Amrit. It was sanctioned. Chief Secretary issued instructions, but people were more interested in issuing EPC contracts rather than implementing this digital platform that could have saved much more. I personally wrote on file that the payback period is 1 year only if you implement IMI system. So this is how the IMI system would have worked: pumping stations, OHSR, DMA entry points, DMA critical points. All these are brought on one platform. So every month billing, you know how much water you have put in a DMA and how much water you have distributed. So you don't have to do any extra work to determine what are the losses. Almost all departments, local bodies with respect to municipal water supply are project oriented. Emphasis on performance improvement, including controlling NRW, is very little. There's a little or no capital outlay for reduction of NRW per se in the budget. Most of the pipe infrastructure is laid years back and is urgent need for rehabilitation replacement. There is little or no awareness amongst administrators, managers regarding NRW reduction. The engineering staff engaged in water supply operations are neither trained nor equipped for the task of NRW reduction. They are engaged in the work not related to water supply and work in ad hoc fashion instead of planned operations. There is need for dedicated sales officers equipped with well-trained and well-equipped engineers for work of NRW reduction. The works like NRW reductions are not among populist measures. Politicians are not interested in it. There is no political will for measures like reduction in NRW. Absence of political will, any move for implementation of proposals, programs aimed at reduction of NRW will not get required. Now, I can vouch for it that while I was chief engineer and we proposed for tariff revisions, we proposed for price restructure, they could not cut across the politicians, or we could not get our proposals through. Now, if you have leakages, you can't have 24/7. And in limited water supply, the hydraulic grade level falls and, the tail ends have very, very little pressure. This is a small slide on this. Now, we are in really, most of the water supply are in a vicious cycle. Expenditure is concentrated on metering. Operational budgets are reduced. NRW increases. Revenues decrease and operational costs increase. So we can convert this vicious cycle to virtuous cycle in which leakage reduction and NRW reduction, apart from tariff revisions and other measures, is an important aspect. Thank you all very much for being patient and listening to me. Thank you.
Thank you, Mathur Saab. That was a wonderful and a very, very informative presentation. Of course, non-revenue water, the time allotted is very, very less to speak. You can, I'm sure you can speak for days on non-revenue water with the experience and the knowledge that you have. Of course, very important aspects highlighted, and definitely major important strategies that are required for reduction of non-revenue water was very informative. I would now next like to invite Ms. Shilpa Nischal from CII to take up her presentation. I'll just briefly introduce her. She has got 22 years of working experience in diverse sustainable development issues, particularly related to water resources. And she's been working towards conceptualizing, developing, and implementing various watershed level activities to enable improved water scenario across geographies. She spearheads operations at CII Water Institute and manages multidisciplinary teams comprising professionals for applying integrated water assessment tool and techniques such as WattScan, a GIS and remote sensing based tool that facilitates decision making for improved water resource management. And I presume she would be presenting on this subject. And last but not the least, she has also contributed popular publications, both in the capacity of author and editor. Ms. Nischal, over to you, please.
Thank you very much. And I think after the two very, very informative presentations, I mean, what I will be touching upon is, taking a step backwards in terms of also understanding that what are the certain other aspects that need to be considered when we are looking at 24/7 water supply systems, or we are talking about smart water, or we are talking about water security. So what I'll be touching upon, in the 10 minutes which have been allocated, is that how certain decision support systems are important and critical if we have to ensure water supply, and particularly from the point of view of source protection and source sustainability. Because unless these two aspects are considered, I mean, water will not be intends to do. So just to give a little, I'll just go very quickly over some of these things. Water over the years has been important, but of late it has actually become much more important given the challenges of scarcity which the world is actually facing, and not only India. And in this particular context, what we find is that now water is coming at a center stage. And it is now being mentioned that water is critical and central if we have to achieve all our sustainable development goals. So this is the starting point in terms of where just to bring everybody on the same page as to if we have to ensure business sustenance, water is something which no longer can be ignored. When we are talking about water security, another concept which everybody's been talking about, but what exactly do we mean? It has several nuances. I mean, whenever we are talking about water security, it's access to safe and sufficient drinking water, protection of livelihoods, preservation and protection of ecosystems, water supplies for socio-economic development and activities, collaborative approaches to transboundary water resource, because water will cut across the boundary. It is not limited to a given boundary which has been demarcated. Ability to cope with uncertainties, the risks of water related hazards. I mean, the frequency of floods, droughts, the changing patterns of rainfall, everything is, we are all witness to this. I mean, this is not something that we are talking, out of context. So all these things need to be kept in mind. And what was just said, just before I started with the presentation, is how governance and accountability are critical if we need to ensure that we are in a water secure environment and a society. And it's over here that what decision support systems become very, very important. And as the name suggests, these are systems which support decision. So it's actually, reading it in the other way. So any system which can help in facilitating decision is a kind of a decision support system. At CII Water Institute, we have a very unique system, a decision support system, which is on a digital platform, and this is WattScan. I'm sure many of you have come across this particular tool. So what the tool does is that based on various data points which are spread spatially as well as temporally. So temporally, the data sets are spread over the time period. So we are looking at the rainfall data and the daily rainfall data for almost 25 to 30 to 35 years for a given location. We're looking at the temperature grids all available in digitized formats from IMD, from NASA, from the TRMM data sets. And then along with that, we are using certain data sets, which are the land use, the soil properties, the topography, and along with that, several other physical attributes, which will help in identifying that, what is the water story of the given area where I am. And based on that, then I need to decide. I mean, the decision support system will facilitate as to what needs to be done in that watershed to make it more water secure. So the tool has been applied across geographies. It has been used for water budgeting, for sightings, something which is extremely important, because often what we find is whether it is a water scheme, a water project, an infrastructure, or an industry, water is never given a priority because water is always considered to be a free resource. Then when monitoring of certain projects and source protection, source sustainability, which is what is the focus. So whenever we are looking at 24/7 water supply, I mean, this bullet number 4 becomes even more important, because first of all, it is important to identify the source from which will supply water. Then once the source has been identified, you need to protect the source, and you also need to ensure the sustainability of the source. The tool has also been applied for climate change impacts, how these will impact livelihoods, and also in the context of urban flooding. And today I'll just present only one case study, which we did for a district in Rajasthan, which is Udaipur. So WATSCAN has been applied over scales. It has been applied at a district level, at a basin level, at a watershed level, a plant level, at a city level. So over here, I will just be touching very quickly on the district water resource planning using the tool, and then going forward, the city resource planning, and also how this tool can effectively help in ensuring source sustainability and source protection. So first of all, based on the various inputs, the digital inputs by the tool, there are 4 key outcomes which WATSCAN is able to provide. One is the spatial outcome that you see. This is Udaipur district's watershed. Now here we are looking at the watershed of the district. So what we find over here is that there are certain pockets which are of dark blue shades, and these are pockets where water is getting generated automatically. And this is again an interplay of rainfall, the soils, the land use. Based on all of that, we see that there are certain pockets where automatically will have good water generation. But what is more interesting is to understand accumulation. So what happens is once water is generated, it will not stay at that particular location, because water by its very nature has the tendency to flow. So it will flow and it will automatically start accumulating in certain other pockets. So again, the darker pockets are important in terms of accumulation. So whenever we are looking at strategies in terms of the surface storages, in terms of any structures which need to be put in the context, it is important to see what are these good water accumulation zones which will give me much better effectiveness in terms of the investments that I make. The next outcome which the tool provides is in terms of water losses due to evaporation. All dark brown shades are the shades which are going to be prone to high evaporation, which means that if you construct reservoirs, if you construct surface storages in these areas, the amount which will get evaporated and which will get lost will be much more, and therefore the effectiveness of these particular strategies will not be effective. And finally, we plug in information available from the state groundwater departments on the groundwater levels, and basis which we can also understand that which are the pockets which are likely to experience stress or are already experiencing stress in terms of the groundwater extractions. Now, if you look at these 3 maps, the 4 outcomes, and particularly the 3 outcomes for Udaipur district, what you can see is, this red reservoir which was constructed long back, which is the main structure in Udaipur. The Maharana Pratap Sagar, this particular dam is actually located in a good water generation zone, in a fairly good water accumulation zone, and a low evaporation zone. And what we find is, based on the evidence which is available from the ground, that the whole Udaipur might be facing challenges in terms of water, but this particular structure, which was constructed at that point in time in history, actually will have water available. So, the hydrology, I mean, this is just to basically strengthen the case that hydrology and siting of certain structures using hydrologically viability is actually going to deliver. So based on the study that we did for Udaipur district, and what we were able to arrive at using the WATSCAN, the decision support system, was that where exactly should you be coming up with the surface storages? Where exactly will micro irrigation systems work? Because these strategies are area differentiated strategies. What will work in one part may not be a feasible strategy in another part. So if you have only X amount of money, I mean, should you be investing in a storage? If yes, then where exactly should you be moving forward? So the tool helps in guiding and it helps to take decisions. Similarly, farm ponds. Where exactly should farm ponds be there? Where exactly should groundwater potential areas be there? So it's a complete mapping in terms of understanding that what is my water story? What is my watershed? How am I a part of a stressed watershed or a surplus watershed? And then having understood that, what exactly should I be doing in terms of improving my availability of the resource? Now, when we did the district watershed, then we move one step further in terms of understanding the city watershed. So we did the same analysis using the decision support system. where we demarcated the watershed for Udaipur city. And over here, what you see is the orange boundary is the Udaipur city watershed. Inside the city watershed, all these blue veins like structure that you see, these are the various drainages which are available. Then the triangles, the red triangles are all the lakes. Udaipur is a lake city. And what we see over here is that we have superimposed various layers again, mapped on ArcGIS platform. So black boundary is the boundary which is according to the master plan. This is how the municipal area for Udaipur is actually going to expand from the current red boundary, the smaller one that where you see my cursor. So as per the plan, this particular municipal corporation boundary is actually going to move in this direction as per the kind of the projections which are given in the master plan. So what does this mean for water? In terms of planning the resource, again, we ran WattScan at the city level. The generation maps clearly indicates that there will be pockets within this newer boundary, which will have a patch of light blue, which is not a good generation pocket. Therefore, if we are looking at certain structures, this is certainly an area which should not be considered. And in terms of accumulation, there is one very good pocket of dark blue where accumulation is good, and some of the structures and some of the schemes can actually come in this particular area, which could feed into the expansion of the municipal, the urban control area, which the plan is talking about. So what the tool is actually able to tell you is that if a city has to expand, and there are certain provisions in terms of making investment and planning, how exactly that planning can be made more effectively. So what we did, we also provided a menu of options both on the supply side and the demand side measures, because our own understanding and what also the new draft policy on water is talking about is that even if the last drop of water is saved, unless and until conservation measures are taken, demand side measures are taken, the whole problem of water stress and scarcity cannot be rectified. So what is important is that in one of the scenarios, what we projected is that we took the data from the PHED department, and what we basically found is that in one of the scenarios, if some of the strategies which are taken up, we will be able to conserve water, which will be over and above and will be able to meet the shortfall. And if we're able to further implement a variety of other strategies as well, there is a possibility that a lot of conservation measures will happen, and therefore this situation can completely become a secure from the secure perspective. So the city, rather than being deficit on water in terms of meeting the demands, can actually start utilizing the water and actually can become surplus in terms of the availability and in terms of the supply. Moving from a city concept, the WattScan has been applied in terms of understanding what are the sourcing options. So at CII Water Institute, we undertake a lot of services for the industry. We do periodic water audits. We do aspects such as water status, understanding the neutrality of the industry. So this was a very unique case study in which what the client wanted was that in terms of understanding, where are the areas where if they have to expand tomorrow, where they will actually get water in terms of sustaining operations. So the WattScan was applied to the geography, and this is an area which is closer to the coast. In terms of understanding the potential surface storages, what are the withdrawal points for meeting the requirements, locating areas for rainwater harvesting at various levels. Then also a very important aspect is that if you're closer to the sea, there is always a chance, if you're extracting a lot of groundwater, that seawater ingress could likely impact you, and then the quality also tends to get impacted. So what are the kind of measures that need to be undertaken, mitigation measures in some sense, which can actually arrest this problem, and the business sustainability can actually be met. So recharge pockets, where exactly should those be located such that we could prevent the seawater ingress was also highlighted. Surface storages, again, another case study. This is in southern part of India, where, we actually try to understand based on outcomes again, that what are the pockets where surface storages are going to be much more meaningful. prioritizing investments. I mean, industry these days is completely grappling with the fact where exactly should they be putting the recharge systems? Is it a part of its watershed? So what the tool is able to tell you is that first of all, understand your watershed, understand your boundary, and then basis that understanding, try and see where exactly should these recharge shafts or some of these structures should be. I mean, are they actually helping the watershed? Are they within the watershed? So there was a case study in which industry is doing a lot of work and lot of investment, but this is lying outside the watershed compared to another industry where the activities were done within the watershed. So it's very important to understand the hydrological boundary and the source, the criticality of the source, and thereby protecting the source to ensure sustenance. So this is the last slide, just some food for thought. Industry, constantly, we all know, is moving from a very, very reactive approach to becoming more and more proactive approach. And this is becoming this is also because of the fact that compliances are increasing, enforcements are increasing, standards are becoming more and more stringent. But what is important is that if we have to ensure that there is resource sustainability and water is actually secured, we constantly need to innovate. We need to have certain standards, guidelines in place, and an integrated approach needs to be followed such that we are all able to play our part, as we move along. So I'll stop here. Thank you very much.
Thank you so much, Ms. Shilpa. That was really very nice presentation. And we cannot really agree more with you when you said that water cannot be taken for granted. And this important tool, this important mechanism that has been developed by CII, I'm sure that in the future days to come, this is going to be one of the main weapon. This WattScan is going to be one of the main weapon for the designers, planners, as well as the policymakers. Means this is going to be an inevitable tool for everywhere whenever we want to talk of water and design a process or design a project which involves water. Thank you so much, Ms. Shilpa. I will be now moving on to our final speaker, Mr. G Sasidharan, who will be making his presentation on smart water management. Mr. Sasidharan is an MTech in environmental sciences and engineering from IIT Mumbai. A career spanning over 35 years in Tamil Nadu Water Supply and Drainage Board, he has served the public of Tamil Nadu by providing safe and protected water supply by executing and maintaining various independent combined network water supply schemes right from source to beneficiary. Mr. Sasidharan had received memento from Honorable former President Dr. APJ Abdul Kalam for promoting awareness among the people, that is to implement rainwater harvesting concept in the district of Coimbatore. Mr. G Sasidharan, kindly over to you with your presentation, please.
Yeah. Got it. Thank you very much. So being the last speaker, it seems I have to rush up, it seems. Okay, anyhow, thank you very much for the organizers, as well as CII and Electrosteel, and the respective audience. So the main issue of water is the source. The source is a very critical area, and how we are managing that art of managing the system is very, very important in case of water supply sector. So how you are managing with limited water, and how best we can able to achieve the water supply distribution, controlling the losses. That art we have to we have to study on that, and lot of technologies and these latest technologies are helping us So based on that, today we know that dealing with water in the best possible way is the art that we have to achieve this through monitoring and controlling the entire water supply. That's the technology is also helping. Next. Next. The purpose of an objective is it's a sustainable, how best you are going to maintain it was a sustainable achievement. That is more important. Remote and online monitoring is one of the easiest way to control flow and pressure. And in order to reduce the losses in the network, we have the online monitoring and controlling more than a necessity nowadays. The water loss reduction is one of the best challenges today in the water supply system. Using automatic and electronic devices will help monitoring, controlling leakage in water supply system. The application of these new technologies in water supply systems eliminates not only water wastages, but also provide continuous water supply, flow rate, network distribution, and of course, cost effectiveness and maintaining safe drinking water quality parameters. So what do you mean by SCADA? SCADA means supervisory control and data acquisition. It is a system used to monitor and control industrial process and infrastructure. In the context of water supply, smart water management, SCADA is used to monitor and control water distribution networks and treatment plants, and of course the storage facility. The SCADA systems consist of hardware and software components that work together to collect data from sensors and other devices and process that data and provide real-time feedback to operators. The data collected can include flow rates, pressure levels, water quality, and other important parameters. The component of this SCADA is called PLC. The PLC stands for Programmable Logic Control. The RTU stands for the Remote Terminal Unit. So both the PLCs and RTUs are used to automate the process and control it. So typical SCADA system of a water supply system network covers all these areas. There is water levels, hydraulic pressure, motor speed and temperature, and pumping station ambient humidity and temperature, and motion detection, and pumps on or off control. All put together, it is being monitored by a remote terminal unit and programmable logic controller or intelligent end device is called IED. So with the help of this communication network, and finally it goes to SCADA master user interface. So the control systems and all the above subsystems comprises of PLC-based control panels with accessories and relevant switch gear as per the system requirements. The PLC will have the capability to provide localized communication on technologies such as OFC, Ethernet, wireless, and on wireless technologies like GPRS and satellite communication, etc. The control and monitoring element should further be enabled to communicate the status of their individual locations with centralized monitoring and control center that enables the water supply system to be monitored from one single location for the entire state, city, or town. The common devices that are used in the SCADA system are mainly monitoring and control. Okay, for monitoring parameters, these are the parameters that we have to monitor. That is flow, the water quality, pH and turbidity, and the level of water, and pressure, residual chlorine, and energy. For all these, we have the devices, respective devices, we can able to monitor through these. Flow, in the case of flow, it is electromagnetic flowmeter. In the case of water quality, we have online sensors. Water quality analyzer is there. In the case of level, ultrasonic radar and ladder level sensors, and pressure, differential pressure sensors, and basically chlorine, online sensors are there, and energy, electronic energy meters. At the same time, we must also have the capacity to control certain parameters, the flow, priming systems, the pressures, and mixer operations. For that, we have electric actuated gates and valves, gate valves. Nowadays, we are all using in the systems, and electric actuated valves and solenoid valves, and pressure transmitters in the case of to control the pressures, and PLC control local panel mixer operations. The components of SCADA system, which can be mainly having sensors and controls. The field data interface devices for the eyes and ears of the SCADA system. The field instruments refers to sensors and actuators that are directly connected to water supply system. The different sensors and controls are reservoir level meters, water flow meters, valve position transmitters and temperature transmitters, power consumption meters, pressure meters, and electric valve actuators, motor control switch boards, and electronic chemical dosing facilities, etc. Remote station. The remote stations are installed in remote plants or equipment that is monitored and controlled by a central host computer. A good remote station may be an RTU or a PLC. It is used to collect data from the equipment and transfer it to the centralized SCADA system. It also allows for manipulation of process in remote locations. Signals are also conditioned to ensure that they are compatible with the input and output of the remote terminal unit or the remote station PLC. The communication network is the backbone of the entire SCADA system. The proper network communication refers to the communication equipment needed to transfer data to and from different locations. The media used can be cable or telephone or radio. The central monitoring station refers to the location of the master by a host computer. Some workstations can be configured on a CMS if needed. The central monitoring system is a master unit of the SCADA system. It is in charge of collecting information collected by the remote station and producing the actions needed for each event detected. A human-machine interface program will run on CMS computer. A plot diagram of the entire plant or process can be displayed on the screen for easy identification with the real system. So each input and output point of a remote unit can be displayed with an appropriate graphical representation and input-output readings. So the database analyzing and processing the data gathered by SCADA system. A physically and digital secure place to store it is needed. The historian software collects time-stamped data within the HMI, helping to arrange it into an optimal format for storing it in a database. Most systems also use structured query language or web-based applications to integrate manufacturing execution systems and enterprise resources planning system, making it easier to convert data between different parts of the network. The use of SCADA in the smart water management, in case of river source, we have various components. You must be knowing that the water pumping station. Out of that, the river sources, if it is a location is a river source, we should have the monitoring parameters with levels. So various levels are there, and we can able to control the floors. And in the case of pump houses, the monitoring parameters of level, flow, and energy, the control parameters of primary system and the flow. In the case of water treatment plants, we have, the subsystems, aerators, flash mixture, alum dosing, clarifier, filter beds, backwash system, backwash water circulation system, and chlorine dosing, and pure water pumping system. So we have the mounting parameters, the control parameters. We have the flow, water quality, pH integrity, flow meter of alum, water quality, pH integrity, level and pressure, and level and pressure. And in the case of flash mixture, it is a mixer operation to be controlled. And in the case of alum dosing, the flow of alum should be controlled. And in the case of clarifier, it is clarifier operations. And in the case of filter bed operations of regular backwash and drain modes. And in the case of backwash system, it is primary system. So the water pumping stations, this the underground elevator service reservoir, or elevator service reservoir, underground level service reservoir, underground service reservoir. So we have to monitor the levels as well as the flow. And if we look at the location, in the case of pump house, the level, flow, pressure, energy, and in the case of primary flow. In the case of distribution systems, whether it is gravity or pumping, we should know the locations, bends, valves, and key point locations. We have to monitor both. The monitor and control both flow, pressure, pH integrity, and flow. So the advantages of smart water management through SCADA is that we can able to monitor real-time monitoring, leak detection, and NRW. So as my previous speakers was telling very interestingly on the NRW, the aim of all these 24/7 water supply is that we have to control this non-W water from 35% to 15%. So that's the aim. So for that, real-time monitoring, we can able to monitor that. The SCADA system can able to monitor the water systems in real time, including water quality, flow rates, pressure, and other key metrics. This can provide valuable insights into system performance and enable early detection of issues before they become significant problem. And the leak detection. So nowadays it is a lot of equipments are coming, and the piping systems have improved. And especially in my experience, I should say that these DA pipes are doing excellent job. So fix it and forget it. That's the experience that I had. And the energy management, this SCADA system can monitor energy usage in water systems, optimizing energy consumption and reducing energy consumption. And the remote control, this SCADA system can provide remote control of water systems, enabling operators to adjust system settings, turn pumps are on or off, and monitor performance from anywhere with secure internet connection. And of course, we have the challenges. The main challenge is the high initial cost of implementing a SCADA system. These systems require specialized hardware and software, as well as skilled personnel to install and maintain them. The other challenge is the need for ongoing training and support for operators. SCADA systems can be complex and require specialized knowledge to operate effectively. It is important to provide ongoing training and support to ensure that operators are able to use the system to its fullest potential. In case of scenario in India is that almost all the major cities are focusing on 24/7. Of course, right from the source to the distribution point to the end point, it is with the help of this SCADA, we can able to monitor the entire activity, and we can able to regulate, we can able to achieve this. In the case of Coimbatore, I am living in Coimbatore, Tamil Nadu, and here the 24/7 water supply scheme is in progress. And out of 100 the wards, we have achieved some the 24/7 in 6 wards. Nowadays, the people are educated in such a way that they know that they don't want to store it. And at the same time, they are ready to pay. and they will use it with care, and they take more care in the usage of water. So the wastage is minimized, and we could achieve the target that is being fixed. That is, the NRW is being reduced from 35 to 15%. So the Jal Jeevan Mission program is there, and Amrut too. All these teams are focusing on the introduction of this SCADA system, and the schemes are being monitored, and we can able to achieve that. So water management, the concluding part, I should say that water management systems and smart water technologies are essential for ensuring a sustainable future. By investing in these solutions, we can able to improve efficiency, reduce costs, and ensure that our water sources are managed effectively. The implementation of various solution tools such as sensors, smart meters, and SCADA can bring about real-time database and information management, and thus improve the performance of urban local bodies and water utilities. The ability to monitor water supply and distribution system on a real-time basis shall enable quick identification, prediction, and prevention of potential problems such as the burst water main, the slow leak, the clogged drain, or a hazardous sewage inflow or overflow contamination. Together, we can ensure that our planet's most precious resources managed effectively for generations to come. As far as the Tamil Nadu is concerned, I should say that we have nearly 544 combined water supply schemes, and out of this, daily we are pumping 2090 MLB of water, and it covers nearly 4.5 crores of people out of a population of 8 crores in Tamil Nadu. And to highlight, I should say that there are two districts called Dharmaburi and Krishnagiri, of which there are 9,000 habitations, which are entirely covered by means of this relay pumping system, and the entire system is called Organical Water Supply Project, and it's being monitored by means of the SCADA system, and it is functioning efficiently. So thanks to the efforts of the technology, and of course the people who have worked in that, and people are enjoying good, safe, and quality water. So ultimately, that is more important. So thank you. I have two video clippings.
Sir, we're not able to open these videos.
Okay, then leave it. Yeah. So thank you very much, sir. Thank you.
Mr. Sasidharan, you would like?
Yeah, thank you. Thank you.
Right. Thank you, Mr. Sasidharan. I think Mr. Lahiri is trying to. There are a lot of questions that are coming in. We have.
The most important component for the smart water management.
It's not audible, sir.
And I will recall 20 years ago when we were doing project in Jhalawad under PHED Rajasthan. I think Mathur Saab will be remembering the same. That's the first time we encountered SCADA. Am I audible?
Yes.
Yeah. So
Go ahead.
20 years ago, when we first installed SCADA system in the Jhalawad project under PHED Rajasthan, when Mathur Sab was the chief engineer's special project. That was the first time we encountered SCADA, and it's really wonderful how this SCADA PLC and RTU can work and make the water management so easy and convenient. And that is really the key to success and key to the 24/7 and NRW reduction. No doubt about it. Thank you so much, Mr. Sasidharan. We have got many questions. We'll be taking a couple of questions. Okay, on water pricing. Given the new strategy that is being discussed, what is municipality response on cost recovery, and how are they planning to implement financial security measures? This is a question from CII. Dr. Narula, whom would you like to address it, please?
Okay, no, these are questions, Mr. Lahiri, actually, these are questions which are coming on the common board. I'm basically transferring them. So I think this has been Mr. I think it could be answered by Dr. Dhinadhyalan or Mr. Agam Mathur.
I will answer. See, if you are really converting intermittent to 24/7 water supply, financial sustainability is a major issue now. We are recommending one aspect in the manual, in the financial management chapter, that whenever the schemes are prepared to convert 24/7 water supply scheme, all ULBs, not only for any 24/7, any scheme, we actually make mistake. The planning, at the time of planning, all ULBs do mistakes. They will carry out to, they don't follow proper procedure. What is happening? The water is used as a political tool. The ULB notify water tariff for a period of 4 years, 5 years. We are recommending one measure in the manual that when projects are formulated and approved by the government, state government, at that time, when the project is approved by the state government from administrative angle, they have to approve the water tariff for a period of design period of 30 years. I think that should be made mandatory in order to ensure financial sustainability, the water tariff to be planned and designed for next 30 years. I think this way things is going to improve. We'll be able to improve financial sustainability in terms of recovering O&M costs. In future, recovering the capital cost. This is what we are coming out in the manual.
Okay, thank you so much, Dr. Dhinadhyalan. And I'll take one more question on capacity of on-ground staff. Given so much of new concepts of digitization and management, is the staff ready to understand it and implement or operate such a system? I think this question can be answered by Mr. Mathur.
Take this question. Well, we have a solution for overall operation in this. What I have suggested is that presently the cadre available in department and municipalities, they are civil engineers, maybe electrical or whatever. There are no CAD operators. So in my proposal, which I put up, that the agency, the private agency, which is going to supply the software, the hardware, and they will also supply the personnel to operate the GIS using the digitized maps. And this digitization is not one-time job. It is a continued process. So when you digitize your assets, pipelines, your operations, what you need to do is supporting order has to be issued from the government or department or municipality that whenever you lay a new line, the bill cannot be passed unless it is marked on a digital map. And that number, like PRN number, whatever you say, like recording measurement book pipeline is to be recorded in the digital map, then only the payment is to be made. So this is not a rocket science. So if you have a GIS operator supplied along with the hardware, software, then it would run. There is no need of training. Yes, what you can do is you can make the higher staff aware of what are the capabilities of GIS, how to get information, how to create queries, because GIS is kind of an open platform. And then, what I have perceived is that in the GIS model, you connect consumer to the pipeline to a DMA, and DMA is connected to a particular zone. So when you do a DMA, if the DMA meter reading is coming to you through SCADA, and then if you are doing consumer billing and putting the same on the platform, then that consumer through GIS is automatically linked to the DMA meter, and you can calculate the NRW. So what I propose is that a complete system, not in bits and pieces, of the digitization should be handed over to a private company, which can develop a specific software and implement, including billing.
Thank you, Mr. Mathur. That was nicely replied. I will take one last question, and this one is very important. And in fact, this was something which I was also jotting it down. This question, I think, goes to Dr. Dhinadhyalan. It's regarding the mindset of the people, and basically it is very important in the perspective of 24/7. Water is viewed as a free resource and as a basic right. Getting private operators has always been a challenge. Do you see change in conventional mindset, and how?
See, when mobile phone are introduced in 2000, we did not have the mobile phone that time. We are only using this old instrument all through telephones. Technology came in. So people started engaging mobile phone after 2005. Now everybody using smartphone. I feel sitting in Government of India, personally, or maybe as an official from Government of India, I tell you, the post of advisor was created in 1953 to improve environmental hygiene in the country. It is my duty to promote best practices in terms of water and sanitation. I was the first person to prepare Swachh Bharat mission for the country. If you see my biodata, you are not ready. I was the person to promote Swachh Bharat mission before the BJP government came into power 2014. I initiated action to promote sanitation through manual. Manual was done under my distinct guidance. It was done in 2013. Now, after 75 years, it is the duty of every environment engineer. See, all are talking about safe water. What is safe water? To tell me, any engineer, what is the definition of safe water? Is it not the fundamental duty of environmental and public health engineer to provide safe water to the household? What is the definition of safe water? See, government should give priority. No, it is not that people. See, people started using, you see the generation, last 70 years. People used hand pumps, open wells. Then they gone for tubal based in. Why CPHEEO was created, you know? Before independence, the country was having a lot of cholera and typhoid. Many people died. The Government of India, they did not do what to do. They wanted to create environment engineers at the central level. CPHEEO was formed. We have to improve water quality. I am telling you, 24/7 water supply is not sophistication. It is a fundamental, basic necessity for the people. So we should not compromise. We have to initiate action. We have to do all, like Swachh Bharat mission was launched. How the situation was? Situation was different in the country. Now, after launching Swachh Bharat mission, there were a lot of IEC activity, lot of awareness. We need awareness for water also, clean water. See, we are saying the paper only, even in the existing manual, we have to provide safe and reliable water. We don't know the definition of safe. Safe means it should be safe from bacteriology angle, biological angle, and other parameters, other chemical and other parameters. That is called safe, free from all the issues. That is called safe water. It is a duty of, fundamental duty of every ULB to provide clean water. This is what I can say. I don't have answer for this directly. We must do, it is a duty of every ULB. They are made for that to provide clean water supply to the household. We have to do that.
Yeah, surely, Dr. Dhinadhyalan, 24/7 is the future, what India is looking
Yes.
at. And we are looking at experts and basically the leaders and who will handhold this policy. And definitely in the years to come, we'll see that 24/7 is as successful
Yes.
as it has been in maybe the National Highway and the sewerage HAM projects.
I would like
Thank
to,
you, Dr.
I would like to highlight only one thing.
Yeah.
In government of Orissa, which is not a very, very developed state, when the government of Orissa is taking up 24/7 only 44 towns, why not other cities, other states? You have to think. See, we don't want any fund and all. Only we need drive. We need to have willpower, the motivation. With that, everything can be done.
Sure. I think that is exactly
that
what
people will come and ask you. No, it is the government duty of the government to do that. Whether it is central ministry or state government, ULB, we are mandated to do safe water supply. We are not, actually we are deceiving people. We say safe water, but we are not supplying safe water. Why? That there is issue in the planning, in the water supply system. We need to change our planning approach. This is what we are proposing DMA and operational zone to have control on the measurement of water, how much is supplied, how much is consumed. Not only that, to prevent contamination of water in the pipeline. This is what our approach should be. Okay.
Thank you. Thank you.
Mr. Lahiri, although we have run out of time, but some very special request for Mr. Sasidharan has come from the participants. They want to understand how many municipalities the SCADA system has been successful for an end-to-end functioning.
As far as Tamil Nadu is concerned, I think it is a organical water supply project where we cover nearly 9,000 villages and 22 municipalities. 22 municipalities. I think that can able to achieve. And of course, all the major schemes in Tamil Nadu now after this Amrut 2 and the Jal Jeevan Mission, it is being insisted that we should have this facility, and so that we can able to monitor and control the entire activities from source to the end point. So that is possible. Only thing is that the cost of the initial cost is very high, so that we can't avoid it. But anyhow, once it is implemented, the usage we can able to really experience it. That's very, very important. That's also helpful for the local body to achieve the financial target, and they can able to give the safe and protected drinking water. Of course, the piping system, we have the latest pipes and all that, and of course, equipment's also there, and we can able to monitor the entire network from the distribution point is very critical, because the DMS, we have to control the DMS in such a way that we have to achieve the equitable distribution. At the same time, the safe water have to be distributed, and the revenue from the water usage. So all these factors are integrated in such a way that this SCADA is helpful. Of course, we are enjoying the facilities, it seems. In Coimbatore, as I said earlier, the 6 wards of this town is it is successfully implemented, and people are now the usage of water is being regulated properly, and the wastage is minimized. That is the experience that I can able to see.
Sure, yeah. Thank you. Yeah, Mr. Lahiri.
Yeah, thank you, Dr. Narula. Before I hand over the session for final conclusion, I will just ask Mr. Pankaj Poddar to quickly give his views on this wonderful session and the wonderful topics that we had from the speakers. Mr. Poddar, just your final views, please.
Well, I must say the level of knowledge that has been shared today, whether it's on 24/7 by Dr. Dhinadhyalan, or we are talking about the NRW, where Mr. Agam Mathur came in with his wonderful inputs, or we talk of different technologies. Shilpa ji talked about the watt scan and how SCADA is helping us. It just shows that we have the technology. India is probably adopting technology faster than most countries in the world today. And with technology, with the I would say the knowledge that we have in this vast country as to what we should be doing, and if we have the technology, if we have the knowledge of where to go, I think, like it was very rightly put by Dr. Dhinadhyalan, what we need is the will. We have the resources. What we need is the will. And today, I'm very thankful that we have so many participants who have joined in this webinar, where CII and Electrosteel has tried in its small way to put all these technologies and ideas for a sustainable and a healthy water supply network in this country. Like Shilpa ji said, every drop counts. So we all have to put our heads together, and it's our responsibility as engineers. Dr. Dhinadhyalan said that it's the responsibility of every engineer, every environmental engineer. It's not a luxury. 24/7 is a responsibility and a necessity. So I think there's a lot of responsibility on our shoulders, and we together, whether it's CII as a lovely platform, whether it's different organizations, whatever they are doing in terms of connecting to the water space, we all have to put our heads together and bring the country much faster towards a sustainable and healthy water supply network that will encompass almost all the population as soon as possible. And I thank all the participants for coming in and spending time. And I think we'll all go back with more wisdom, and we will try our best to achieve this.
Thank you. Dr. Narula, over to you, please, for concluding the session.
No, I think Mr. Poddar has really concluded very well. The only piece that I can add to it is, where there is a will, there is a way. And I'm sure, I think we will get there. We will certainly get there. And I think today's discussions are a beginning to it. And with this, with the webinar series that we have started, together, I think they will be taking on, on this way. They will be taking us, from one step to another step. And we will certainly see, a lot of these changes in mindsets and behaviors that we are actually discussing, be it with regard to adoption of new tools, new techniques, new data systems, new way of thinking, new kind of science and implementation to it. I am sure changing mindsets and behaviors is the way forward, a big way forward. It's a very important step. And these webinar series will certainly apply themselves towards this and in this direction. So I really compliment and thank you to all the speakers. Wonderful kind of discussions, wonderful kind of presentations, new thinking, new concepts.
I would add one thing,
have been better than that.
Can we have a webinar next on a pricing strategy? I would like to give input. And then one thing more to be added, as far as technology and this is concerned, we have revolutionized our telecom sector. There was so much resistance of bringing in private sector, but the technology helped the poor the most. Likewise, in water sector, if we are able to do innovative contracting, and it will reduce the cost of water production, and it will benefit the poor the most, because the rich and the mighty, they can always organize their water. They can bring the bottled water, but the poor, they are the worst sufferers when we don't get water, even with after payments. So thank you very much.
Thank you. I think it's a point noted, sir. We have noted the point that you've just mentioned, and also Mr. Dhinadhyalan, Dr. Dhinadhyalan also mentioned about a very important aspect, quality. And I think it is quality also these days. We are receiving a lot of, new things on quality with regard to emerging contaminants. And I think, it will be, this is a very, I think, as you rightly suggested, pricing mechanisms, quality, SCADA. On SCADA also, we want to really see how
Contracting mechanism, most important is contracting mechanisms, transparent contracting mechanisms,
Sure.
regulators. What you have to think of the end consumer, how they can be benefited, how the cost of production of water and distribution of water can be brought down.
Sure.
We do
Certainly.
it in the running system, or we have to have innovative system.
Sure,
Thank
certainly.
you.
So Mr. Poddar, there is a lot of work that we need to do in terms of, bringing all these important discussion points on the in the forum. So I'm sure, Mr. Poddar and, the Electrosteel Castings and CII Water Institute will do justice to all the topics that you are referring to. And also one request on telemetry and SCADA systems. We need to have one more. They say we need to have a seminar, webinar on the same as well. So I can see some 5-7 topics emerging from this itself, which the participants are saying they need to have advanced discussions on, including what Dr. Mathur has also mentioned. So
Yeah. As for telemetry and SCADA, all this concerned, we will give you the live demonstration of what we have imparted in the Bisalpur system. That was one of the best in the country when we implemented it in 2009. That
fantastic,
is the state of the art. So we can bring those videos and slides for information of the participants.
Fantastic, sir. That will be really wonderful. So we will organize another one very soon, together with Electrosteel Castings as a series that we have begun. Once again, on behalf of Electrosteel Castings and on behalf of CII Water Institute, let me thank all the speakers, eminent speakers over here. We look forward to your continued support in raising this awareness and changing mindsets and behaviors. We will come back to you with further requests, towards coming again with us on these webinar series. And on behalf of everyone over here, all speakers, all everyone, I must thank all the delegates who have been, very patiently, continue to stay and join us. Although we have far exceeded what we had planned for in terms of timings, but very thankful to you for continuing to stay with us and for your kind patience. And we will continue to come back to you and work with you in taking this mission forward. Thank you so much again.
Thank you so much.
A big thank you to everyone. Thank you.